Hello, everyone, and welcome to AI Images. This week, we start our dataset dissection classes, which is why we've got a cybernetic frog in my background. We're going to look at what happens inside these datasets. What are the images that make them up? And you're going to have an opportunity to dig into these datasets and look at them for yourself. So I want to talk about why we're going to do this first, and then today's class is going to be a walkthrough of that assignment. So here's why. When engineers want to teach a machine how to see objects in the road, for example, one way to do it is to look at the ground. When objects on the ground interrupt the line of sight from that vehicle, in theory, it's going to send a response to the brakes of an autonomous vehicle and stop the car. So basically, you have a clear line of sight, clear road, something comes into the road, the car stops. This is the theory, and this is machine vision at work. In 2017, Volvo had trained its autonomous vehicles to look for objects on the ground to avoid collisions, just like that.
So we're here from Volvo Cars Sweden on a data collection expedition. We're here to collect data for kangaroos and hope that doing so will enable us to provide functions that can avoid or mitigate collisions towards kangaroos.
But it couldn't account for kangaroos. When a kangaroo jumped, the system read it as moving further away to the horizon. So you imagine sort of flat ground. The car is scanning this flat ground to see if anything comes into the road or if there's a rock in the road or something like that. And then all of a sudden, it doesn't know it's a kangaroo. It doesn't know if it's a rock. It doesn't know what it is. All of a sudden, whatever is there is suddenly, boom, it's back here. And then it's on the ground again. And then it's back here. And then it's on the ground again. It doesn't read it as up because it doesn't expect things. It was never trained to learn that anything would jump. So when you're a company like Volvo, which is based in Sweden, and you're designing cars for animals, one of the things you're not thinking about when you're thinking about collision is kangaroos. There are no Swedish kangaroos, at least not to the scale that it's a large problem with your autonomous vehicles. They were trained on European land animals, for example, things like elk and caribou, or maybe things in the American market, so they could sell their cars here. But kangaroos were a completely different story. And when a kangaroo jumped, they may as well have been wizards. The machine saw it as being on the ground and then suddenly just somewhere far off in the distance. And as a result, it didn't brake when it saw kangaroos. And this was a problem if you want to sell cars in Australia. Machines don't understand reality. They understand models of reality that we have described to them. These models are described through data. To get a system working, we have to translate our observations, our knowledge into data, and it has to be limited by the constraints of the system too. So if a camera can't see in the dark, it's not going to be very useful, right? It doesn't matter what model we give it. So it's a combination of the data and the system. So someone decides what matters most to get the system moving and working, and the observations that relate to what we want to teach the machine go into our data. But the least important stuff is going to be discarded. We're not going to put information we don't think the machine needs into the data set. So if we are designing a car that needs to stop in Sweden, we do not tell it about kangaroos. And by the time these cars get to Australia, it's too late. The system has already been trained and tested, just never on kangaroos. So this is what we're thinking about. This is a metaphor for a much larger issue around data sets. We have subjective judgments and frames of reference. We come from certain places. We come from certain cultural assumptions. We come from certain backgrounds. And there's no need to warn a system about Swedish kangaroos if we've never encountered one. Lots of problems can worm their way in through the gaps that are left when we have discards. When we discard information from a data set, we have these gaps that can remain. And even more come through when the data set gets adapted to other purposes that maybe aren't even intended when we initially collect that data. Or maybe we collect the data and hand it off to someone else, and someone else does something that we don't expect with it. These are the types of things that are constantly happening in image training data sets. So if we're collecting images of one type of person or one type of place, and then we're moving that data to somewhere else, it's going to be much harder for that information to be relevant. It's going to be harder when we're talking about generation. It's going to be harder for these models to generate information if all they have is information about a certain particular place, or most of what they have is about a certain particular place. Catherine D'Ignazio and Lauren Klein, who you read, talk about this idea that most data arrives on our computational doorstep context-free and ripe for misinterpretation. And context becomes extra complicated with poor data documentation. Data documentation is part of what we're going to be talking about today. We've talked a lot about data collection in image sets, and now we're going to do a full-on dataset dissection. We're going to pick a data set. You are going to pick a data set. You're going to open it up, and you're going to see what's inside. And here's the reason why. First, as Kate Crawford and Trevor Paglin write, training sets are the foundation on which contemporary machine learning systems are built. They are central to how AI systems recognize and interpret the world. These data sets shape the epistemic boundaries governing how AI systems operate, and thus are an essential part of understanding socially significant questions about AI. In other words, we study training sets because if we want to know what an AI is giving us and what an AI is doing, we have to understand the data that it is using. Second, data sets used for making AI-generated images come from many different sources, which are created for many different purposes. On the one hand, remember, if you want to generate images with GANs, you needed specific categories of images to train it with, and then the GAN could make more images of that category. Diffusion models are taking in all kinds of images from all kinds of different sources, but many of those sources are still these massive data sets that were used for GANs, or the ones that GANs used, because these data sets predate GANs. They're about machine vision. So they're teaching machines to see things and understand the visual world long before they were used to generate new images. So we have these massive data sets, pretty large data sets, that have a bunch of images sorted by a specific category tied to a specific purpose that people wanted to teach a machine how to understand. Things like what's in the road, things like sign language, for example. If I can get a data set of my hands doing certain types of sign, then perhaps you could train a machine to read sign language when it sees it, right? So these are the purposes that this information is collected for. So some data sets are built for specific purposes. Some are built specifically for image generation, but data sets are pretty hard to make. And once you're done with them, they sometimes don't serve much more purpose. So you can find lots of data sets being freely shared online, and they're often recycled by people who don't really pay attention to where that data came from or why it was collected in the first place. They maybe don't know what decisions informed the data set or what the limits of the data were. And it will help people create meaningful work or playful work or artwork. And they can do that without starting from scratch. But the question I like to ask is, what if we were tourists visiting a new place, tasked with describing what we saw to our friends, trying to convince them to visit us? And what if instead of a place, it was a data set? Our role with data set can be the same way. If we're looking at data sets that we didn't make, though we will eventually make them, but if we're looking at data sets that we didn't make, we're essentially tourists in that data. We need to make sense of what that data is. Now, we can be good tourists and look around and try to understand the sort of culture of that data set. What went into that data set? What were people thinking about when they made it? What's inside? What does it represent and mean? Rather than just seeing a collection of images. So we're going to create kind of a tourist guide to these data sets. How do we make sense of them? How might we decide if we want to use this data set or not? Finally, looking at a data set helps us understand what image making tools see. and how it is shaped for those machines to make sense of. We can get a sense of things like categories and labels, as well as how they've been cropped or prepared for use before being analyzed. We can see who and what is represented in them, and think about how that translates to what is presented when these images are made by these tools. So for this assignment, you're going to be choosing a data set. You can choose your own data set and go into the group in Discord that matches that data set. And a minimum of 2 people is recommended. You could go in there and put your name in if there's a data set that you want. You'll see on Discord there are now a number of text channels that you can go in, put your name on associated to the data set that you want to work on. And if you have 2 people in that group, then you can go ahead and do it. If you have nobody else in your group, then please find a group with 2 people or 3 people, and up to 4 people can do a single data set. So that information is in the assignments for the module, and we're going to walk through the assignment pack. So if you want to open up that assignment pack, you can even pause this video, open up the assignment pack, look at it, and get familiar with it. But we're going to walk through it in just a minute. That's the rest of this class. Looking at the data assignment packet, the data dissection assignment packet or lab report, and talking about basically what the questions mean and how you can look at the data sets on Kaggle. I have 2 examples that are not available for you to use, so we can dive in. So we'll walk through 2 of those in the remainder of the class, and we'll look at how to answer those questions. So I will pause there, take a breath, and in a minute we will flip and you will see my screen, and I will be sharing images of the data sets, and we'll go into exactly what I'm asking for. Now, whether you watch the video or not, I'm going to hold you to the same standard, so I highly recommend you do eventually watch this video, but you can pause it now and go back and make your groups. So here we are with the garbage classification data set, and this is on Kaggle, which you will be using to look at your own data set. So let's look at what's going on here. So let's just read the screen. Right up here, we see who has uploaded the data set. Over here, we see the download button. So this is a pretty large file. And then here we see the data card. So a lot of the work that you're going to be doing in your dataset dissection is already included in the data card. The questions that we're asking, hopefully, will be answered through your data card. And I don't want to say just copy and paste it. Read it critically as if you were reading anything on the internet. Think about what it says. But the data card's here, and here you say about the data set, and there'll be some information here, including this one is conveniently lists how many images are assorted or have been sorted into each category. But let's think about this in a minute, but we'll come back as we read through the page. There's a usability rating, which is calculated by Kaggle. You don't have to pay much attention to this. The license would be sort of, is a Creative Commons license, who can use it? So this one we don't know, which means we don't know what we can do with this as data scientists or thinking about using this data set in a model. We don't know. We don't know what the terms are. Whoever uploaded this did not tell us what the terms were. And then they also didn't tell us when they expect to update it. We do see that it was updated about a month ago, so it's pretty recent. Down here, you see the garbage classification, the directory. So this is the file structure. Not everything's going to have this. If it's a really large file, you might need to download it first. And then over here, you have it broken down into a sort of file tree, folder tree. And you can click over here, and you can see roughly the images. So this is for classifying garbage, right? So when we're talking about sort of what is the purpose, so your first question in the dataset dissection, for what purpose was the dataset created? In this case, this is clearly has been designed for garbage classification. So let's think about what that means. Well, garbage is sorted into 10 classes, and maybe this is meant to help a recycling plant figure out if something is recyclable or not. Probably that's the ideal use. And in theory, we could use this as training data for an image generator, though we might not want to, because when we look at this, we'll think about why. But this isn't actually a great data set for image generation. But we'll talk about that in a minute. What do we see here? Well, we're sorted into batteries. So we have our answers to these questions are already here. Why was this created? Who created the data set? We have an individual who uploaded it. Who funded the data set? It looks like this individual probably just, right? There's no information about that. Maybe there's some collaborators, right? Just one person. Author name and bio is missing. Coverage is missing. So a lot of this information is missing. But that's okay, because we're going to go through it anyway. The point is just to see how Kaggle is sorted out. Down here, you can see who's downloaded it. Looks like 27 people downloaded it on February 21st for some reason. Very popular day for garbage classification. 106 people, 1,030 views. And there's other tools in here too. Related notebooks. So we could see actual uses and tools that are using this data set. So here, this is another question that is in your dataset dissection sheet, is who else is using it? Where has it been used? And finally, you have similar data sets, which you can ignore. These are sort of automatically generated. So, okay, this is the bulk of it. We go through and we say provenance and motivation. We're asking who made the data set and why. So this part one is about provenance, where did it come from? And motivation, why does it exist? We came through some of these questions. For what purposes was the data set created? Garbage classification is in the title, so we can assume that that's why. What are the specific tasks? What was the need for this data set? So what's, like we said, the reason this exists is possibly for helping to sort. You can imagine a camera being used with a garbage sorting location to figure out, is this plastic, is this a battery, is this glass, where does it go? Which bin does it go into? Who created it? We have one individual's name. We don't know who funded it. We don't know what their interest in it was. More than likely, and again, this is a guess, this is a hunch, we're saying whoever created the data set probably funded it. It's probably not that robust a data set. Who actually collected the data? We don't know. So we don't actually know, based on that data card, who collected the data. We don't know if it was a machine that scraped these images off the internet. We don't know if it was a research team. We don't know if this person is a student. We don't know this information. So we would have to say, we don't actually know. We don't know. It's not clear. When was it collected? When was it published? We know it was published about a month ago. We don't know if it was collected at the same time. What was it used for? Well, you can do a Google search, or you can see the related notebooks at the bottom to see how it was used. All right, so we've got that. The next part of our sheet moves to the composition. What kind of data is in the data set? What kind of file formats? What's the size and shape? Are they all the same or different? How many images are there? Let's be specific about the common properties. So it looks like JPEGs. We have a lot of JPEGs. We have a range of kilobytes that we can see here. So we know these files are not very big, right? These are pretty small image files. So that's important. Now this tells us there's 22,000 of them, which is a lot because you look how small these files are and then look how big the actual data set is. And there's nothing else in here. It's just, as far as we can tell, images of garbage. Fun way to spend the afternoon, looking at garbage. Now, if we look at our dataset dissection, we ask what's represented in the dataset. Now, you just heard me say, oh, we're looking at garbage. That's actually not the answer to what's represented in the dataset. If these are images, which they are, not all datasets are images, of course, but in this case, all of them will be, what are they images of? They're actually not garbage. This is not garbage. This is a box of almond milk. And if we look around, maybe that's garbage. Maybe this is garbage, I don't know. When we look at images of glass, is this garbage? This looks pretty new to me. Here's something new, something new, something new. Oh, look, something else we can notice. Here's some watermarks. See these little lines here? This means that they downloaded it from some sort of file repository. So they got this from another database, another data source. This probably isn't surprising to you, but these images were not created by the person who put this data set together. If they were, they would all be consistent. They wouldn't have these watermarks that you see here. So when you look at an image like this and you see something like this, it tells you, okay, they're drawing a lot of different images from a lot of different sources. Clothes. Let's see. Are these garbage? This doesn't look like garbage. So already we have kind of a disconnect, right? We're classifying garbage, and yet all of the pictures, maybe not all, we would spend more time going through the data set. I don't want to know what this is. All right, maybe that's garbage, right? Some fungal bread, moldy bread, moldy bread with Shutterstock. So we know that some of these images have come from Shutterstock. So, okay, we've got the biological stuff, that's garbage. Shoes, are the shoes garbage? I'd wear those. I wouldn't wear those, but for different reasons. So I don't know if these are garbage shoes. Right? This is from Baidu. These are new, like literally being sold. So when we're asked in the dataset dissection, what's represented in the dataset, what are the images of, don't just assume that if it's a garbage training set, that these are pictures of garbage. That's actually a really important disconnect to make a note of. Our next question here is, were these images processed, resized, cut, or cropped? So the way you would answer this is have a look, and you could pick out individual folders. You do random sort of clicking around the way I'm doing here. You'll want to be more methodical at some point, but right now we're just getting a sense of what's in the data set. And we see most of these are square, but they're different sizes. This is pretty big, right? This is a rectangle, and it's a watermark, so they're pretty inconsistent. Some are rectangles, some are squares. Some are bigger than others. So these are actually not really clean. This data is not really has not been cleaned up. No one's gone in there and resized everything to be the same image size. But the one thing that we do sort of see, maybe you've picked up on this already, is the white background. So there's a consistency in the selection, a bias towards white backgrounds in these images. So were these images processed, resized, cut, or cropped? It does not appear that any of that was done. If they're all the same size, we can actually assume they might have been processed or resized, especially if they seem like they're coming from different sources. If there's different sizes represented in the data set, we could assume that they have not been resized, right? Does this make sense? So think critically about what you're seeing. Think about what those images are and how they got to be that way. That's kind of the ultimate question here in were these images processed, resized. Was anything censored or removed from the images? Hard to say with this set, because we don't know what the source material was. But you might see, for example, if you have pictures of people, you might have blurry faces, or you might have black boxes over eyes so that people are harder to identify. You might see that the images have obviously been cropped to focus on something like just an eyeball, or just a nose, or just an ear, which would suggest that what's been removed from the image itself is the rest of the person. Right? We're just focusing on a particular part of a face or body, then that suggests that something has been removed. So censored means the image is more or less there, but parts of it have been blocked to protect someone's identity, or maybe they're censoring up, material that they don't want shared, nudity, that kind of thing. If it's been removed or cropped, then you'll see that as well. This is something you have to infer. You have to think critically about what these images are and how they got to be that way. I'm going to repeat that a few times. Why was it censored or removed? Well, again, if it's just an ear, right, that's probably, if you're looking at the ear training data set, then the reason that this stuff was removed relates directly to the idea that the face was irrelevant to the ear, right? You want a data set full of ear images, you cut out the rest of the data. You focus just on the ear so that the machine can read that ear and learn the patterns of what an ear is. So I hope that makes sense. If it contains people, do you see evidence that they knew or agreed to be included in the data set? We'll talk about this one in a minute. We'll come back to this one. And if it contains artworks, did the artists agree? We'll talk about this one a little bit. If you look at things like the Wikidata art data set, a lot of those artists are no longer living. A lot of that artwork is in the public domain. And so the question of whether they agree is not legally relevant, though you may be interested in that anyway. It's very hard to imagine a 15th century painter would have said, please use my images to train an artificial intelligence program. But think about more contemporary data sets, or think about data sets that have logos, or think about the data sets that might contain comic drawings, anime, Pokemon cards or drawings, or cartoon characters. So if there's contemporary art in these data sets, who gave permission? Was any permission given? Is it indicated anywhere? That might be up here, if there was, in about the data set. It might be down here in any of these things, like provenance would be a good place, because provenance is going to tell you what the source was. And here you see it should contain the collection method, but there happened to be blank on this data set. So, okay. What are the categories? So here we have the list of categories. That's one thing this model does give us, is we have metal, glass, biological, paper, battery, trash, cardboard, shoes, clothes, and plastic. So we know what our categories are. Why do you think they picked these categories? Are there categories missing? What are those categories that are missing? So we can think about this. If we're thinking about this as garbage classification, there's metal, that's helpful. Glass is helpful. Biological, hard to know where that came from, why that's called biological. If we look at this biological waste, right, why is that garbage? Why are bananas garbage? What's this? What's this beetle doing here? Are people throwing beetles away? Why is this part of the garbage classifier? It's an odd choice, right? And so we comment on this odd choice. There's a lot of mold. Lots of mold. So we're going through methodologically now. We're going by each image. We're looking at moldy bread. That bread doesn't look moldy. There's a moldy fruit. Moldy bread. Moldy bread. Moldy bread, moldy bread, moldy bread. So what's going on here that we're noticing? Well, a bias towards moldy bread. There's a lot of moldy bread. There's like 2 apples and a lot of moldy bread. So that's a bias. That's going to lead to disproportionate results. There's 955 more images, by the way. I don't know if you notice, but here, see down here? When you click on the folder, you get more images down here. So click deep into the data set. You can keep going. Maybe this bread is a bias of the early stuff. And you can go through pretty quickly when you do this. Another thing you can do that could be helpful in looking at all the images is just to go into the image viewer, so you don't have to click on all of the folders, and you can quickly get a summary. So now we're seeing that bias that we were seeing is actually a result of maybe just looking early at the data set. But that actually there's a lot of fruit in here. Okay. And we can load more fruit, bread that isn't moldy. So actually, check your assumptions. This is why we look through the data set instead of just looking at the early editions of the data set. I've talked about this before. Try to take a random sample of the data set if you can. Sample from various numbers across the range. Or if you can, if it's manageable, have a look at the data set. You can look at one specific folder if that's helpful and focus on that folder. When you're doing these data set classifications, don't feel like you need to look at all 28,000 or 22,000 files. Pick a folder and break that folder up. So, okay. We're at about 240. We've been scanning these. But I think you get the point, right? So we can go through there and we can just think about what the patterns are. You can actually go in and make an even bigger view. And we can think about what the patterns are that we see in this data set. I'm going to go back. Oops. Garbage classification. Okay. So what's represented in the data set? Was anything censored or removed? We asked that question. What are the categories? That's what we're looking at. What do you think they picked these categories? Are there categories missing? So we got distracted. Why do you think they picked these categories? Well, they probably wanted to pick these for recycling purposes. These are probably recycling categories that are used for garbage sorting somewhere. Maybe not everywhere, but somewhere. So that's these classifications. What else would be useful in the garbage classification? We can think about this. We can brainstorm this. What else would be useful in garbage classification? Large household objects, for example. There isn't a category of large household objects. Anyway. Question 10 is, where did the data come from? Now, this question we've already sort of jumped ahead to a little bit when we saw that some of these pictures came from Shutterstock. Some of these pictures came from sort of Amazon.com, Weibo, these different sort of marketplace websites. So this is actually, we're thinking, we can see that was sort of evident by looking at the pictures because it literally said, right, Shutterstock on the picture. So we have a sense of where this data came from. It came from many places across the web. Did it come from already existing archives? Well, in this case, yeah, it looked like some of them came from already existing archives. Came from, we might not think of Amazon.com as an archive, but it is a photo archive, right? Shutterstock is a photo archive. So we can think about that, where they came from, why did they come from that? Some of the pictures you see might come from Instagram, or they might come from Flickr, where people posted pictures online of themselves or friends and maybe didn't know they were contributing to a data set. Amazon.com certainly probably didn't expect when they put up a picture of bananas to sell bananas that it would be used in a garbage training data set, right? So that's true of big companies. It's true of people. Think about that. Where did this data come from? And where do you think it came from? So that's this section. That's the composition of the data set itself. We've been exploring a lot of different sort of rabbit holes around each of these questions, but most of this is going to be pretty straightforward. You just say what it is. What kind of data is in the data set? Tell me, right? You can reflect on it. Why do you think it is this? What's represented in the data set? What are the images of? Were they processed? Just tell me the answer. You can reflect a bit, but really we're just looking for factual information in this section. The next section is where I'm going to ask you to work as a group, look at random images from the data set, try to look at about 100 images, and as you look at these images, quickly jot down any notes about patterns you find across these images. These patterns don't have to be in every image, though sometimes they will. Remember that these images were selected for similarities, so if you can't find any patterns, maybe you need to think a little bit bigger. So the patterns that we would see in the garbage classification website, for example, when we look at pictures of cardboard, these white backgrounds, that's a pattern. But look how easy it is to look at more than 100 images, right? We're looking at 100 images here. So really you want to look at more than 100 images to get a sense. You want to skim through a folder as best you can to get a sense of what's in there. Right? So let's move away from the garbage data set and look at another one. This is the Celeb A faces data set. Now this one has a little bit more information. So before we get to this dissection, we're going to just go up and look at these questions again to give you a second example. For what purpose was this data set collected? Well, there's a lot more information on this data set, right? So here, if you read it, it's going to tell you, this data set is great for training and testing models for face detection, particularly for recognizing facial attributes such as finding people with brown hair, smiling, or wearing glasses. So that's interesting. So this is a data set created for that purpose. What was the need for this data set? Well, they tell you too. Large pose variations, background clutter, diverse people, supported by large quantity of images and rich annotations. So it's telling you why they collected it. They're telling you a popular component of computer vision revolves around identifying faces. So that's why they did it for various applications, from logging into your phone or searching for surveillance images for a particular suspect. So that's why this was created. Gotcha? So they're looking also at more poses, more background clutter, diverse sets of people, and a large quantity of images. So what is that? How many images are there? Well, it's a gigabyte. We don't really know. 203,000 files. So we open this up. We can go in here, and there we go. Now we are looking at the images. And this is just one massive data set. It's not categorized by anything except for celebrity faces. That's the only information in this data set. There's no categories. So when we go back here, when we ask, right, we scroll down, what are the categories in the data set? There are none. The data set is celebrities. So why do you think they picked these categories? Are there categories missing? What could those categories be? Well, how would you classify celebrities? What categories would you put celebrity faces in? Do they need them? Talk about that a little bit. Who created the data set? Let's look at this. We'll scroll up. So here we go. This data was originally collected by researchers at MM Lab, the Chinese University of Hong Kong. So we know that. And then if we scroll down here, we know who the collaborators were, the owner, the person who uploaded it. Authors are not listed, but we know the lab that made them. Provenance doesn't tell us the provenance, doesn't tell us where stuff came from. Do we have a license? Other, specified in the description. So let's look up at that. We can read more of this. This tells you the breakdown of what's in there. Acknowledgements. So somebody made the banner. That's not really important to us. Non-commercial research purposes only. So you can't use this to generate ads or make stuff to sell. If you use this data set to generate a face, you can't sell the face. So that's interesting. So what if this ended up in your diffusion data set and you generated an image? How does that work? It's a good question. So they were inspired by a couple of questions too, which is interesting. Can you train a model that can detect particular facial attributes? So this is about image detection, not generation. It'd be interesting to note that this is from 2015, which means, if you remember, when were we doing GANs on a massive scale? They probably weren't anticipating, when they started collecting this data, they probably weren't thinking about generation. And yet, it probably was used in at least somebody's image generation set, right? They were looking at which images might contain people smiling. They wanted to have an image recognition system that could detect that. Does someone have straight or wavy hair? Okay. So who created the data set? We answered that. Who funded the data set? We don't know, but it's from a university, so we could safely say that the university was responsible for this. Who actually collected it? Again, we don't know. They don't tell us. We don't know if the student team did this stuff or if it was machines that did this stuff. When was it collected? We saw 2015. When was it published? We scroll up here and we see up here 5 years ago. This was published in 2018. So this actually predates some of the GAN stuff that we saw, like thispersondoesnotexist.com. What was it used for? Well, let's see. We can scroll down to the bottom if you remember. Related notebooks, so gender detection. Making fake faces, so somebody did use it to generate faces, though we don't know if it was necessarily for commercial purposes. And then here, generate realistic faces. So this is interesting because this is a data set that was made for face recognition, and yet people have downloaded it and used it to generate real faces based on these celebrity faces. Another thing that's kind of fun to look at is the discussions. Who's talking about this and what are they talking about? Maybe there's more information in here. And if you pull information from here, mention it because it takes a deeper dive. And then here's a list of notebooks that draw on that data. So, okay. We have an idea of what it was used for. What kind of data? Well, again, we go in, we look at the data set. It's JPEGs. Looks like a lot of JPEGs. They're sort of numerically sequenced. Celebrities from 2015, little Huey Lewis. Again, there's 205,000 of these images. You do not have to look at all of them, but try not to look at them in sequence. Don't go 1, 2, 3, 4, 5, right? Jump around. Try to get a random sample. Try to break this up between members of the group and look at a large sample of them. Okay. Size and shape of these files. They look to be pretty consistent. There's some errors. I'm noticing an error there. Some errors there. This looks like it might be censored or cropped. So this is something that takes a little critical thinking when you're looking at these images. There's this common sort of recurring weird pattern where something seems like it's been censored. So what do we think that might be? You might start looking around and start thinking about that. What is that when you see it? We may have seen a watermark. Nope. So up here, there's a black bar. What's going on there? This seems cropped or censored. So, okay. So you get the point. Harder to say where the data came from with this one. You can look around. These are celebrity faces. There might be some additional information. This is interesting too. It tells you how the image recognition system what it identified. This might be interesting for you, but it's not necessarily something you have to look at. Okay. So again, here we go. We're looking at a wide variety of images. So what patterns do you see? Well, they're all celebrities. Tell me how many pictures your team reviewed. What patterns do you see? Give me a one-word description in bold, then a sentence or two describing what you mean. So, for example, all of them were centered. All 100 of the people in the images that we looked at had their faces in the center of the image. Actually not the case with some of the images that we saw in this data set. What's missing from the data? Well, for one thing, we're looking at a data set of celebrity faces. So what's missing are non-celebrities. That one's pretty easy. But you might also look at other elements. When we define celebrity, whose celebrities? Might be worth looking at. Are there K-pop idols in there, for example, that would reflect sort of celebrities in Korea or China? Or is it just sort of European and American celebrities, right? Are there actors and actresses from India or Iran in the data set? Might be hard for you to tell, because if you don't know who these celebrities are, then how are you going to know? But you can sort of ask it as a question, right? So you don't necessarily have to tell us that you know for a fact that something is missing. You can tell us that you suspect something might be missing and that it would warrant some further research. So let's get into the reflections. Here we're talking about what you learned, what you thought about as you went through this data set. And as a group, I'm asking you to select 3 questions that you want to address. So there's a list here of 7 questions, and you can choose 3 that you think are the most relevant to the work you're doing. And one of them is what's something interesting or striking about the data set that surprised you. So this one is kind of a catch-all. It's kind of a make up your own learning. Tell me what you learned, even if it doesn't relate to these other questions. But to go through it, do you think this data set is representative of the category it aims to describe? Well, for example, the garbage classification data set didn't contain a ton of garbage. A lot of the stuff that was listed as garbage was actually not garbage. So it was like new products. So that might be something that you would say that wasn't representative of the category. If you went and you typed garbage into Stable Diffusion or DALL-E 2, and you got a perfect picture of a new bottle of milk, why would that happen? Well, part of it might be because this data set got in there a little bit. Now, that's unlikely to be as directly correlated as that, but it's something to think about. It's something to think about in the individual data sets. So that's an example of something that was not representative of the category it aims to describe. Likewise, with the celebrity data set, you could say, well, yeah, these are all celebrities, but whose celebrities are they? Right? So are they representative of celebrities, or are they representative of European and American celebrities, or are they North American celebrities, or are they representative of global celebrities? How are they defining celebrities? What's the category? And what's missing that could be included? With the garbage data set, obviously, you could include pictures of actual garbage. That would make it a better data set. So the other question, question 15, that you might choose to answer is, why do you think these images were originally made? What might have been the creator's original intent for making them? This is not about the data set. I'm going to add that in now. This is not about the data set. It's about the images in the data set. In other words, these celebrity pictures, why were they made? They were probably made for journalism, right? For magazines, for websites. A photographer probably went out and got paid to take a picture of Avril Lavigne or Huey Lewis, and they got this picture. They might have been used for promotional uses, right? The record label wants to say, here's a new label, a new record, here's a picture of the artist. And so they would have this picture. But take a look at them and think about, where did they come from? Something with the celebrity one, for example, you might notice is a lot of them look like they were at events. So they were at sort of award shows or sort of red carpet events, and that's why these images were originally made. When you look at the garbage data sets, well, let's think critically, right? We saw white backgrounds, new products. So where do we think those might have been made? Well, they were probably made for websites that sell these things, right? So we can infer this. Be careful about what you infer, right? Know the limits of your knowledge, but be clear about that limit, right? Tell me that you suspect that they were made for one reason or another. If you can prove it, then great. If it says so in the data card, then great. If you can find the images in your data set in another context, then say so. But for the most part, you're probably going to infer these things. And I want you to think about why you think they were originally made and what might have been the original intent for making them. And you can think about, what using them in an image model like these would do to that purpose, right? Does it respect that purpose? Does it disrespect that purpose? I'll actually put that in. Does the model respect that purpose or change that purpose? Okay, hopefully that's clearer. The next question is, did you notice any biases in the image selection, or the people represented in these images? For example, if it's a collection of selfies, that would say all of the people in that data set have cell phones because they're taking pictures with selfies. If it's a collection of 20 fruit categories, where are these fruits coming from? Are they American fruits? Are they South American fruits? Are they Asian fruits? Is it actually globally representative, or is it representative of a single place? There's a question of, how do you feel when you're looking at the images in the data set? I oftentimes find myself feeling a little weird when I look at these images, because I get the sense that the people I'm looking at, when I'm looking at people, didn't know I'd be looking at them. And I feel a little strange sometimes, but that's just me. You might feel different emotions as you are looking through these images. So don't feel constrained, and it doesn't have to be a negative emotion, right? Maybe the data set you're looking at makes you laugh or brings you some joy. Why? Why do you feel this way? Why do you think you felt this way? So tell me why. And this can be done individually. Not everyone in the group has to feel the same way. A few of you might take different parts of this question and answer it on your own. The next question is, what would you like to know about the data set and the things contained within it? This could be any part of the system, from people or things in the images to the way the folders are organized, how it was collected, etc. Think about it this way. If you could talk to the person or group of people that put this data set together, what would you ask them? You could also frame this as the people who took these pictures or the people in the pictures. What would you like to ask them? And why would you like to ask them? What would it help you to know? What would this help you to understand? Question 19 is, if you were to collect this data set, what would you do differently? Think practically. This is about how you would organize the information based on some of the stuff you've thought about by going through this exercise, right? Using the reflections you've taken, what would you do differently about building this data set? So I know, for example, that if I were building a garbage recognition data set, I would use pictures of garbage. That's what I would do differently. Likewise, I might actually sort the categories for celebrities into different categories, especially based on the fact that it was designed to recognize people with glasses or to create people with curly or straight hair, for example. Would we want to put those into categories of straight hair, curly hair? What does that make possible if we do that, right? We can then see that specific subcategory, but what does it also mean we can't do? To take those images out of one category and put them into another. So if you were to collect this data set, what would you do differently? How would you collect it differently? How would you organize it differently? Where would you get the information from? Just what would you do? And finally, we already covered it, but what's something interesting or striking about the data set that surprised you? Maybe it's something you didn't expect. For example, as you can probably tell, because I've talked about it a whole class lecture, I'm very surprised that the garbage data set doesn't have garbage in it. I mean, it has some. I'm aware that moldy bread is moldy bread, and I'm not going to eat that either. But I guess my question is, isn't it surprising how much of the stuff in the garbage classification data set was new products? What would that do if you were thinking about this as a recycling plant that was going to use this data set, right? Would it be reliable? What if it was crushed? What if your milk carton was crushed? Would it say, oh no, that's not a milk carton. You put that in the regular, that can't be recycled, right? So think about that. What's interesting? What did you think about that was surprising? And that's that. That is the exercise in a nutshell. So that's it for this class. The next 15 minutes, if you haven't made your groups and found your groups, please do that. Please have this done by the end of the day, just for your own sake, so you are sure to get the group that you want. And that's that. The next class, to be clear, is a working session. So you will come together. There is no recording, no class video, just you and your teammate or group working on your dataset dissection. So everything we talked about today, you have class time in the next session to work on. And if you have any questions, of course, feel free to reach out on Discord. I think that's it. And then we will present these. You can check on the schedule and you'll see when they are due, just before the spring break. So you have a working day and then they're due on the class before spring break. So thanks so much. And feel free to ask me any questions you have on Discord. See you there. Bye.